is 1. You can only convert when it's 1. So what's the exponential form of this going to be? What's the base over here? So the base stays the same. So what's the base? So it's 6 to the equals the square root of 216. What is 216? You need to know what it is. You just have to know. It's a power. 6 to the... Nope. You have to know what it is. You're going, 6 to the 6 is like a million. 6 to the third. Okay. What does square root mean, everybody? To the power of 1/2. So this is 6 to the third to the 1/2. What do you do with powers of powers? Multiply them. So you now have 6 to the x is equal to 6 to the 3/2. So therefore, what does x equal? 3/2. Yep, there it is. One really nice thing about this is that the bases are all the same. The bases are all the same. That means we can actually use all the rules. Later, are you going to deal with logs that don't have the same base? Yes. But right now, we're just in the same basis. So if we want to combine this all together, we need to get rid of all the things that are coefficients that are 1. So what can we do with a coefficient? This was happened last class. What can you do with this 3? Yeah, so this turns into log base p of x to the third plus log base p of y to the minus, and I'm just going to keep the minus there, log base p of z to the, I'm just going to just bring up the 3/2 instead of bringing up the negative, it's fine. And then minus log base p of what? A to the third. So these two right here, when you deal with these two right here, what does addition mean? So you have log base p of x cubed y to the 1/2. And then you have minus these two things. So you could factor out a minus if you wanted to, but what does minus mean? Division, right? So you have minus these two things right here. It means divide. So what do you end up with? You end up with log base p, and what do you have on top? X cubed y to the 1/2. But then what do you put under it? Z to the what? 3/2. And then you have minus this other one, right? This is the same one. So this one right here is log base p of z to the 3/2. And this one's log base p of a cubed, like this. So then you just divide again. So what does it become? Log base p of x cubed y to the 1/2 all over 3/2. Say 3, like this. Put it together. Yep. Dividing by a fraction is the same thing as multiplying by the reciprocal, so it also goes to the denominator. Yes, Nate? 25 on 10.4. Okay, so how's this one, though? Do we understand this one?
Yeah.
Before you combine. Log base A of. So you have log base A of r over s plus log base A of t to the third. So now what do you do when you, oh, it's multiplication, so it's just going to be log base A of, what's on top? RT cubed all over. Correct. The 3 and the 4, so that's going to be log base A of 5 to the minus log base A of 3 to the 4th. But what does minus mean now? So it's log base A of, and I love using the parentheses here, 5 to the 3rd divided by. Done.
You can't simplify that.
No, there's nothing to simplify on that. No.
You can't do a 5 times 5 times 5 divided by 3 times 3 times 3 times 3.
You could, but that doesn't get you anywhere that you want to go. This is where you should stop right here. You could, if you wanted to, you could rewrite it as log of 125 over 81 if you wanted to. That's fine. Log base A if you wanted to. No, because if you no, there's nothing, you can't, because remember, log of A over B does not equal log of A over log of B. You can't do that. That's one of the things you can't do. That's one of those things. Remember I told you it's really easy to make a rule up. You just don't really know it. That's the easiest one, I think, to make up. Divisible base when the base isn't written in. It's 10. Exactly, right? So take it. Go ahead.
If we like on a constant base, we did that.
Here at the bottom, pH, which you've probably seen before, maybe chemistry, measure of acidity or base, is sometimes measured using numbers like 6.3 times 10 to the negative third. So you sometimes will have to plug numbers like this into your calculator using logarithms to find actual pH values. Like sometimes you have a concentration and you have some formula that'll pump out the pH. So do this for me right now on your calculator. Do this and keep the number up on your calculator. I'm going to ask you for it. Hey, look at that. And you rounded correctly. Very good. Excellent. So now you actually get to generate some actual logarithm values. So what they ask you in this section, they ask you a whole bunch of different like word-based, word problems, and they're not that bad. They basically come down to just plugging the right numbers in, and then you would need to know the actual decibel level of the sound. The actual decibel level. If a particular sound has a density, then the decibel level. So how do you go about doing this if you were given some numbers? Well, you could be given some numbers like this. You could say, let me plug this in here, right there. Oh, I'm going to pause that and redo it. You're taking this number right here and you're plugging it in for I. So D is going to be equal to 10 log of 3.162 times 10 to the 9th I naught all over I naught. How do you simplify that? What can you cancel? You can cancel the I naught because everything on top is being multiplied together. So you cancel. And now, can you plug this into your calculator? 10 log of 3.162. Do this on your calculator for me. 10 to the 9th. Do that for me. Something that's that close to an actual integer value. Exactly. Tell me this right here. This is called the change of base rule. Your goal is to figure out for me why this is so useful. One question here. Let's say I asked you this question. Log of 7 of, let's say, I don't know, 40 equals something. What form is that in? Is that log form or exponential form? Log form. It has the word log in it, right? So can someone put it in exponential form for me? 7 to the question mark equal. Yeah, exactly. Now, can you give me an approximation of what that's going to be? It's going to be greater than something and less than. No, not 6. 7 to the 6th is huge. So this right here, what's 7 to the 1st? 7. What's 7 squared? Yeah, so maybe like 1.8, right? 1.7. But do you really know? Not really. So what this does is allows you to use your calculator to find the value of any log you want. Here's why. Look what it says. It says log base a of x is log base b of x over log base b of a, where b can be anything you want. What's a base you really like? 10. So what does this mean? It means that log base 7 of 40 is the same thing as log base 10 of 40 over what? Log base 10 of 7. You can now, with this change of base formula, pick any base you want. And do we have a calculator button for log base 10? Yeah, do this for me. Do log of 40 divided by log of 7. Remember, log is log base 10 on your calculator. Figure this out for me. Tell me what this decimal is to 3 decimal places. When you have it, just raise your hand and I'll call on you. Give it to 3 decimal places. Yes? You couldn't get the what? Okay, do this one now and then come back to that. What do you get, Hannah?
I have 1.896.
Who agrees with that?
Yeah.
Is that about what we estimated it to be? We thought it'd be less than 2, right? No, do this on your calculator for me. Okay, so on your calculator, everybody hands up for a sec. You did something like this, right? You did log of what, 40? I like doing that, divided by log of 7, right? I just like to see the numbers. Did you get that right there? You can do this. Do you know about the store button on your calculator? If you hit STO in the bottom left and hit alpha, you can store it as A or B or C. Every time I do A now, look what it gives me. What should 7 to the A power be? Should be 40. Oh, look, it is. We can test it, right? So what does this mean? Let's go back again. Let's say I asked you, give me any number you want, Nate. Something more exotic than 10. 14 of 2.3. Tell me what that equals. Tell me what log base 14 of 2.3 equals. Actually, you know what? Make it 20. Let's make it 2,300, okay? There you go. This is literally what we just did. You pick whatever base you want. So you started with log base 7 of 40. This is you only have base 10 and base e on your calculator. So you pick any base you want. So what is this going to turn into right here?
Log 200.
Log base 10 of
2,300
over Of 14, yes. Of 14, exactly. Exactly. Log base 10 of 2,300 over what? Of 14. Exactly. What'd you get, Katie? Try this on your calculator for a second, everybody. Do ln of 2,300 divided by ln of 14. Tell me what you get. What should you get? You should get the same thing. Do you get the same thing? You do. You typed something wrong there. Take a look. It's in a book. So here's the deal. On your calculator, it doesn't matter which button you press, log or ln. Not generally. When you're writing things out, if you have to choose, I like choosing ln. It's kind of cool. But literally, I've seen 2 algebra textbooks. They cover the exact same thing. One book uses log 100 million times, and one book uses ln 100 million times. And the only difference is that like one little piece of text, one little letter. Okay. Keep going, Rourke. What's 50?